Hello everybody, welcome to a short discussion on my project. I am doing a fully automatic 3D reconstruction for some symmetric shapes. Here is what I'm going to discuss. I'll discuss the problem, some solutions, my setup, the insights of my setup, and the results. So let's discuss the problem. The problem is 3D is hard. 3D modeling is hard, 3D reconstruction is hard, even 3D viewing is hard. Here is how you model a bottle. Take a photo of a bottle, try to get it to be placed somewhere in the 3D screen. Take a cube, fit it manually, moving all the edges, do it 100 times, then find an image, try attaching an image, and then you finally get a 3D model. So, what's the solution? Maybe doing it in 2D. Here are some ways that you can do it. Drag some shapes. They'll fit into the model, or click and drag across the model, and that will fit into it. So the key idea is fitting. Here is what I've done. Take a photo, clean it up, let it fit. Let me show you some demo. Here is a photo of a can. Here is a reconstruction of the same thing. Let's try something that's more time consuming. Here is a bottle of Coke. Here is a 3D reconstruction. Well, the shape is pretty close. I might need to clean up some textures. Well, this I can use as is. What we are basically doing is fitting. For fitting, the first thing we need is segmentation. We assume that the user provides a clean image, no dirty edges because that fails 3-sweep anyways. And we use grab cut to get the object mask. We are assuming that it's a cylinder, but you could imagine a machine learning system that could tell us that this is the bounding box and this is the extrusion for a cylinder or a cuboid. Then we go to the profile phase of 3-sweep. In the first phase of 3-sweep, we sweep across Y, then we sweep across X. Based on this, we can get the angle of the object. For the front view, the sweep across X is removed. The sweep across Y is simplified as in to find the top left and sweeps right. Then we do the third phase of 3-sweep, that is sweep across Z. That can be done by sweeping across the edges and finding the average. Right now we've taken an assumption that's a straight sweep. A lot of work is needed to clean this up. Luckily, the Savitsky-Golay filter does the job for most of the cases, apart from maybe some outlier removal. When we do the extrusion, we get a pretty close object in the 3D world. We still need to map the texture. We have a very good idea of what the texture is. Unfortunately, the tool that I was using, VPython, doesn't support proper UV mapping. So I had to work around with the cylindrical mapping and created a cylinder that could be mapped to. The results, it works when a grab cut works and we have a front view. Doesn't work in other cases. Grab cut can be improved with bounding box detection. The frontal view assumption can be improved. Instead of using that, we could use a perspective assumption that the object has minimal scales. So you have to find out what is the angle based on which you can get minimum scaling. Thank you. Feel free to post questions.